Okay, in our next example, we have parameters of n equals 100 and p equals 1/5. So before we even start, let's just picture a scenario here. Perhaps we are tossing a 5-sided shape and seeing what side comes up. Perhaps it's got colours or numbers on it, something like that. So a probability of 1/5, and we're going to toss it 100 times. So when we find mean variance and standard deviation, we really need to imagine that I'm tossing my 5-sided shape 100 times, and I'm going to see how many, red sides come up, or how many 3s, or whatever it is that I've decided success is. But not only am I doing this experiment 100 times, perhaps a whole heap of people, a whole class perhaps, or maybe everybody in the school is doing this experiment, and everyone's tossing their 5-sided shape 100 times. So that when we all call out how many red sides or 3s or whatever it was that was success we got out of 100, we could then average that out and see what was the mean, what was the variance, what was the standard deviation. So the mean and the variance and standard deviation should be very simple to find. The expected value, or mu, is going to be n times p, which is just 100 times 1/5. And it makes a lot of sense that if we run this experiment a lot of times, that we might be expecting that the most common thing that would happen, or the mean, the expected value, would be that we'd get 20 of those red sides if we're tossing a colourful 5-sided shape, or whatever it is that we've decided success is. That's very logical. So now the variance of x is going to be npq. So we have 100 for n, we have 1/5 for p, and then q, remember, is 1 minus 1/5, so that will be 4/5. So that gives us what? 400 divided by 25, which is 16. So then the standard deviation is going to be the square root of 16, which is nice and simple, 4. Okay, for the second part of the question, what n value, if we keep p the same but change n, would allow the standard deviation to be less than 1% of n? Now, there's lots of ways that you can set this out, so whatever you think of, just go for it. What we're trying to do is let the standard deviation, now we know the standard deviation is 4, but we don't want to use 4, we want to use the formula for it, which is npq in the square root bracket, because we're changing some things, and we want that to be less than 1% of n. Well, 1% of n is just n divided by 100, so I think I'll write it like that. We could easily have 0.01 n, there's many ways you could set it out. Now, we are keeping p the same. It makes sense that we already know, if we already know that p is 1/5, then we already also know that q is 4/5. So on the next line, I can do a couple of things at once. No, let's just do one thing at a time. Let's take the square of both sides so that we've got npq. And over here we'll have n squared over 10,000. And now we can consider that we're changing n, so we want that to be a variable, but p times q, we can figure out on the side over here, is already something we know. It's 1/5 times 4/5. So that's 4/25. So we've got 4/25 n is less than n squared over 10,000. Now again, from here, many ways to solve it. You could get rid of fractions, you could get everything on one side and factorise. Lots of strategies. How about we get rid of fractions by multiplying both sides by 10,000? That's going to give us 1600n over here is less than n squared. So therefore, if we get everything on one side, n squared minus 1600n is greater than 0. At this point, I can see that this is, if I graphed y equals n squared minus 1600n and y equals 0, I've got a parabola here. And factorising it, I can see that I've got zeros at 0 and at 1600. So I'm picturing a parabola like this. Remember, we solved a lot of problems like this in year 11. And I want my parabola to be above the line. So I want this section or this section. So in other words, I want n to be less than 0, or n is greater than 1600. Now, what is n? N is the number of trials, isn't it? Can I have less than 0 trials? No, by definition, not doing any trials at all is the minimum. So this part makes no sense, and I would say that n has to be greater than 1600. Okay, for part C, let's work over on the side here. We need to keep n as 100, But we're going to change P, and we're considering what would P need to be increased or decreased to. Now remember, P is the probability of success. What could it be so that the standard deviation was less than 1? Are both options possible, increasing it and decreasing it? Well, what would make P be impossible? P is a probability, right? So it's got to be a number between 0 and 1. So think that through at the start, and we'll see what we get. All right, we're keeping n equal to 100, but we want the standard deviation. Now, the standard deviation was 4, but again, let's use the formula for it. We want this to be less than 1. Now, we're keeping n as 100. In other words, we've got 100 PQ is less than 1. This is my thinking here. But also, I don't really want two variables. This is one of those situations where if I'm going to change P, Q is going to change with P, isn't it? So it makes more sense, really, to say let's call this 100 times P times 1 minus P. That way I've only got one variable, and now I can solve this in terms of P. All right, let's square both sides to get rid of the square root bracket. And if we're squaring both sides and saying something had to be smaller than 1, then it makes sense that squaring it still has to be smaller than 1. Yep, that seems okay. So now we've got 100p minus 100p squared, and if I subtract 1 from both sides, I get this, and I've got a quadratic situation similar to what I had over there. I think this would be easier to solve if I multiply everything by -1, just so I've got an upright parabola. Not essential, it's just something I sort of prefer to do. So I've got multiplying that by -1 changes the sign. I can change the sign of p's, change the sign of the 1s, and obviously if I multiply by -1, I need to change this sign as well. So now conceptually I've got a parabola here where on the p-axis I want to find the intercepts. Now, easiest way to find them, I can see that I'm not going to be able to factorise this, so I can throw the formula at it and find the two values that would be intercepts of this upright parabola, so that I can see if I want the parabola to sit above the line. I'm picturing something like this. I'm not sure where it sits, but I want this section and this section, right? So I need to find where these intercepts lie. So to find the intercepts, let's just say P equals, and we'll throw it into the quadratic formula. We need -b, so that's 100, plus or minus the square root of b squared, so that will be 10,000, minus 4 times 100 times 1. So that gives us this all over 2a. All right, tidying this up a little bit, we get 100 plus or minus, now this is the square root of 9,600, so it comes out as plus or minus 40 root 6 over 200. I can simplify that by dividing all three terms by 10, and then I can halve all three terms as well, which gives me, to write it a bit more tidily, 5 plus or minus 2 root 6 over 10. All right, now, the question said are both options possible, so we'd better put this into our calculator now and actually see what we get. So if we have 5 plus 2 root 6 over 10, that gives us, so remembering what we were finding here, we've got some kind of parabola. It would need to be bigger than the biggest, so P would have to be greater than 0.989, 99, let's go to 4 decimal places, or P would have to be less than, if I change it to the negative option, 0.0101, also to 4 decimal places. So P has to either be really big, almost as big as it can be, it's still less than 1, so I think it's still possible, or really, really small. So I think, yes, both options are possible. So we would say, yes, both are possible because they're numbers that are between 0 and 1.